So we're going to add and subtract polynomials. Addition and subtraction of polynomials. All right. And you guys are somewhat familiar with polynomials, hopefully. Right? A polynomial, a lay term might be one or more terms. Like if I had 5x squared plus 3x minus 11, this would be an example of a polynomial. There are three terms here. Right? This is a three-term polynomial. So this would be classified as a trinomial. Right? This is just a quick review of this trinomial. This would be a second degree trinomial because the highest exponent in any single term, in this case, is a 2. So this is a second degree trinomial. And the leading coefficient in this case is 5. The leading coefficient is the coefficient of the term that has the highest degree. Coefficient of the term with the highest degree. Right? So we have three terms, 1, 2, 3, right? And they all have coefficients, 5, 3, and negative 11. But the degrees are all different. This is a second degree term. This is a first degree term. And 11 is actually a 0 degree term. Okay. So that would be a trinomial. A binomial would be a two-term polynomial, right? I could have a 3x to the 5th minus 9. This is a binomial. And if I asked what degree, this would be a 5th degree with a leading coefficient of 3, right? Because it's the coefficient of the term with the highest degree. And then you can have a monomial, which is a single term polynomial, you know, like 4x, we'll call it 4x squared. This is a monomial, right? And this happens to be a second degree with a leading coefficient of 4. So these are all polynomials, special types of polynomials. You know, you could have a 10th degree polynomial or a 5-term polynomial. You could have like a 7x to the 6th minus 11x to the 5th plus 4x to the 3rd minus 6x squared plus minus 10. Right, this is a polynomial. Again, I said a lay term for a polynomial would be one or more terms. Another thing to keep in mind if you go on a pre-calc is a polynomial has to have non-negative integers as degrees. Non-negative. So 0 is non-negative, so that was okay. And 1, 2, 3. You can't have fractions. You can't have x to the negative 1/2. It can't be negative, and it can't be a fraction. So you couldn't have x to the 3/4, or you couldn't have x to the negative 3. Non-negative integers. Non-negative integers are 0, 1, 2, 3, 4, dot, dot, dot. So your exponents always have to be non-negative integers. And it's always a good idea to put your polynomial in standard form. Standard form is in descending order of degree. Right? So my degrees, just out of habit, I always do them from highest to lowest. That's standard form. 6, 5, 3, 2, 1, 0. So it's in descending order of degree. So that's a short review of polynomials. This section wants us to add and subtract polynomials, which is relatively easy. Our first example says 3x squared minus 7x plus 11 plus 4x squared minus 9x plus 5. And the directions will say add. So when we're adding polynomials like this, well, if you wanted to have a procedure, if this was a beginning algebra course, I would say what I want to do here, if you think procedurally, is I want to remove the parentheses. And I want to get rid of these parentheses. And the only way to remove parentheses mathematically is by multiplication. You take what's on the outside and you multiply it to what's on the inside. So in this case, we could assume there's a 1 on the outside, right? 1 times anything is itself. So you're really just multiplying a 1. So you'd be left with 3x squared minus 7x plus 11 plus 4x squared minus 9x plus 5. Some professors say when you're adding, you could just ignore the parentheses, which you can ignore the parentheses, but mathematically, that's not what's going on. You can't just pick and choose what you want to ignore and not ignore. Really, what's going on here is it's the multiplication of 1, and that's what's removing it. And that's why nothing changes. 1 times anything is itself. Once you remove the parentheses, I would suggest you identify the like terms. Right? Like terms have to have the same variables raised to the same powers. So like in this case, I have an x squared, and here I have an x squared. Those are like terms. Here I have a x to the first power, and here I have an x to the first power. Those are like terms. This value is a constant, and this value is a constant. Those are like terms. Once we identify our like terms, we want to combine like terms. Right? So here I have 3x squared plus 4x squared. Now, I don't know what x squared is. I don't know what the value is. I don't know what it is. It could just be an empty box or apple or something. I have 3 of these, and I'm adding 4 of these. So together, if I combine them, I have 7 of these. I have 3x squared plus 4x squared will give me 7 of these, 7x squared. Same thing here. I have a negative 7x and a negative 9x. If I combine them together, a negative 7 and a negative 9 is a negative 16x. Here I have an 11 and a 5. That gives me positive Right? So when I'm adding, and you know about adding like signs, a -7 and a -9, I think of it as I owe my brother $7, I owe my mother $9. So together, combined, I owe $16. You're combining the values. And that's it for addition of polynomials. Subtraction of polynomials is exactly the same. If I have 4x squared minus 13x plus 5 minus 5x squared minus x plus 9, and I asked you to subtract these polynomials, well, we would follow these same procedures. We want to remove the parentheses by distributing what's on the outside. We want to identify the like terms, and then we want to combine the like terms. You want me to give you a second? Let me give you a second. So let's assume there's a 1 out here, and there's a 1 out here. I distribute it in. I'm going to have 4x squared minus 13x plus 5. And over here, I'm going to distribute this -1. I'm going to have negative 5x squared. Negative times negative is positive x. Negative times positive is -9. Right? So you're distributing that negative. So it's going to change all the signs there. Once we distribute our what's on the outside, our -1 and our +1, we want to identify our like terms. So I'm going to put my x squares together. I want to put my x to the first power together, and I want to put my constants together. I'm going to identify my like terms, and then I can combine my like terms. I have 4x squared minus 5x squared will give me a -1x squared. A -13x and a +1x gives me a -12x. And a +5 and a -9 gives me a -4.
I have a question.
Yes.
It might sound weird, but doesn't for the first part, for the 4x squared, wouldn't the, like, I don't know how to say it, but like it's like 4x squared minus, is that not -5x? Like you don't see it like that because of the like the symbol in front, or no?
It's 4x squared
Yeah.
minus 5x squared.
Oh, I put 4x squared minus and then negative. I saw that as -5x squared.
It wouldn't be minus negative, right? Unless
Oh.
that was a negative there. Then it would be minus negative.
Oh, but that's just
4x squared
changing.
minus positive, right?
Okay.
We're good?
Okay.
Okay. Let's try another one. What if they said subtract 4x squared minus 9 from the sum of x squared plus 5x and x squared minus 7x minus 11. And here you have two operations. You have addition and subtraction. So why don't you take a second and try that one. Let me start this a little bit. Let's see. We're subtracting this from the sum of these, right? So I'm adding this, and then I'm subtracting those two. So I could write this as x squared plus 5x plus x squared minus 7x minus 11 minus 4x squared minus 9. So that would be your setup. You could say you have to do this first. You could put big brackets around that because it says to add that first. Now, if we're going to add this, we distribute what's on the outside. So we're going to have x squared plus 5x plus x squared minus 7x minus 11. We could do this all at once, or we could add this first. It doesn't make a difference. Since it said the sum of this, let's find the sum of this first, just to work this out first. So this will give me 2x squared minus 2x minus 11. Right? That would be the sum of that. And then if I brought this down, I'm subtracting 4x squared, and I'm subtracting the negative 9. So it looks like my final answer, I combine my like terms, I'm going to have negative 2x squared minus 2x minus 2. That's peculiar. So that's as easy as adding and subtracting polynomials. All you're doing is removing your parentheses and combining your like terms. In this section, it moves on to do multiplication of polynomials. So let's look at that.
Professor?
Yeah. So let's continue on with multiplication of polynomials. And in our first 3 examples, we're going to look at a monomial times a monomial, which is a single term polynomial times a single term polynomial. So if you had something like, for example, 4x squared times negative 3x to the 5th, right? When we're multiplying a monomial times a monomial, we would multiply the coefficients. And in this case, we would get negative 12. And then we would multiply variables. And when we multiply variables, you know, you have to keep the base and add the exponents. So in this case, I have x to the 2nd and x to the 5th gives me x to the 7th. In this next example, we're multiplying a monomial, a single term polynomial, to a trinomial. And this would work if it was a 3-term polynomial or a 2-term polynomial or a 10-term polynomial. It doesn't matter. We would do the same operation. In this case, what we want to do is distribute what's on the outside to all the terms on the inside. Distribute term outside to all terms inside parentheses. So we're going to take this 2x cubed and we're going to multiply it to each one of these terms. And again, when I multiply, I follow this same procedure. I multiply the coefficients, and then I multiply the variables, which means add exponents. So I'm going to have 2 times 1. This looks like 2x to the 5th. 2 times negative 7 is a negative 14. X to the 4th, because that's a first power, plus 10x cubed. We just multiply our term on the outside to all the terms on the inside. In this next example, we're multiplying a binomial to a binomial. Binomial is a 2-term polynomial. And a lot of students in the past learned this as a FOIL acronym. First, outer, inner, last. I'm not a big fan of FOIL. I'll refer to it from time to time, but I like to do it more mathematically. Really what we're doing is we're just going to distribute this first term to both of the other terms, and then we're going to distribute the second term to both of the other terms. Right, so my procedure is distribute first term into the parentheses, distribute second term, and then to simplify it, we're going to combine like terms. So I'll do it in 2 different colors so we can see. So here I have x times x, so that's going to give me x squared. And then x times a negative 7 will give me a negative 7x. So that's my first step. I distribute the first term. Now I distribute my second term. Positive 3 times x gives me a positive 3x. And a positive 3 times negative 7 gives me negative 21. I distribute my first term. I distribute my second term. Now I can combine my like terms. These are like terms. They're both x to the first degree. So I'll have x squared minus 4x minus 21. And that's how you multiply a binomial to a binomial. That's what foiling is, right? When they say to FOIL, they say multiply your firsts, that's your firsts, then your outers, that's your outers, that's what we did, then your inners, and then your last. I had a hard time as a student grasping that concept, so I don't use FOIL so much. But FOIL is what was taught when I was a kid. First, inner, outer, last. Another reason I don't like FOIL is because if I'm going to multiply a binomial to a binomial, I could just distribute terms. And if I do a binomial to a trinomial, it's going to be the same procedure. And FOIL would not work for this. And if I do a trinomial to a trinomial, it's the same procedure. That's why I like this procedure. It's constant. It's consistent. It works for all problems. FOIL doesn't work for all problems. FOIL only works for a binomial times a binomial. So if I have a binomial times a trinomial, if I have x minus 2 times x squared minus 7x plus 5, I could use the same procedure. I could distribute my first term, distribute my second term, and then combine like terms. So why don't you take a second and try that problem. So I'm going to start this problem. So I'm going to distribute x to each one of these. So that's going to give me x cubed minus 7x squared plus 5x. And now I'm going to distribute this -2. Don't forget to include the negative. So -2 times x squared is, I'll do it in blue, -2x squared plus 14x minus 10. And then I can combine my like terms. So I will have x cubed, -7x squared, and a -2x squared gives me a -9x squared plus 19x minus 10. I believe. We all agree? No questions or concerns? I could turn the page. You could always watch the video. Hopefully I'll post it. In this section, they could ask you to do a trinomial times a trinomial, which is really a pain in the neck, very tedious. If nothing else, it's just a practice multiplication, because the procedure is easy enough. So here you're multiplying a trinomial times a trinomial. The procedure is the same. We're going to distribute the first term, then we're going to distribute the second term, then we're going to distribute the third term. Identify your like terms, combine your like terms. I'll give you a second. So in this problem, because it's so lengthy, if I distribute my first term to all three of these, it's going to give me 3 new terms. And when I distribute this one, it's going to give me another 3 terms. And when I distribute the 1, it's going to give me another 3 terms. So I'm going to have a string of 9 terms here, which is a little bit of a pain in the neck. What we could do when we distribute, I have 2x squared times 3x squared. That gives me 6x to the 4th. And 2x times a -2x is a -4x cubed. 2 times 5, this gives me 10x squared. So I multiplied my first term. Now when I multiply my second term, what I could do is I could do this vertically. So instead of putting it next to it, I'm going to put it underneath it. So -7x times 3x squared is going to give me a -21x cubed. So I'm going to line up my cubes. -7 times a -2 gives me a positive 14x squared. And a -7 times 5 gives me a -35x. And now when I multiply my 1, I'm going to do the same thing. I'm going to line them up. 1 times 3x squared is 3x squared. And 1 times -2 is -2. And 1 times 5 is 5. So normally we would just have these in a long line, but this way I have them so they're all vertically lined up. All my like terms are together. So I have a 6x to the 4th minus 25x cubed. 10 and 14 is 24 plus 3 is 27x squared minus 37x plus 5. I hate that problem. Too long. When you move on to pre-calc, if you're moving on to pre-calc, there's some shortcuts, especially with binomials. There's some we'll call special binomials. There's two shortcuts, and if you could identify them, it'll save you a lot of time. So if you have a binomial squared, this is the first one. If we have something like x plus 3 squared, there's two ways we could approach this. The more remedial way to approach this is to expand it, right? X plus 3 squared really means x plus 3 times x plus 3. And then you would distribute, and you'd have x squared plus 3x plus 3x plus 9, if you do all that math. And then you would combine your like terms, and you'd have x squared plus 6x plus 9. That would be a fail-safe way of doing it, right? It would give you the right answer. Hopefully you're comfortable with it. But there's another way of doing it. And there's a formula for it. It says if I have a binomial squared, a plus b squared, that's going to be the same as a squared plus 2ab plus b squared. Which sometimes seeing formulas is a little bit of a problem. It might be overwhelming. But really all it means is I'm going to square my first term, right? That's what that is. And this is the square of my last term. Right? And that's what we have here. We squared the first term, and that's the square of the last term. And 2ab means I multiply these two terms, and I times it by 2. I multiply these two terms, and I double it. So really what's going on here is square your first term, multiply the terms, the two terms, and double it, multiply it by 2 afterwards, and then square your last term. That's what that formula says. So if I have something like a 2x plus 7 squared, instead of expanding it like this, I could just square my first term, which will give me 4x squared. 2x times 2x is 4x squared. I could multiply these two terms. 7 times 2x is 14x, and then double it. 14 doubled is 28. And then square my last term. 7 squared is 49. Square your first term, multiply your two terms and double it, and then square your last term. This will help you a lot in pre-calc. It's a big shortcut. Your professor is never going to do it this way. They're going to see a binomial squared, and they're going to jump to the answer. The problem in pre-calc or higher level math is the algebra. The pre-calculus or calculus is easy. And what makes the algebra hard is your professor is not going to teach you algebra. They're going to jump over and skip steps and expect you to know the algebra. And that's what makes it confusing, because you'll go from here to here and you'll be like, hey, what the hell did they do? How'd they get there? So it's important, if you're not grasping it, to go over your notes when you're in a higher level math, because the reason you're not grasping it is because they're leaving out a lot of the, middle work, the algebra. And to prove that this is the same, you could check it. You don't really, this is ridiculous, but I just want to show you. So this would give me 4x squared plus 14x plus 14x plus 49. I combine my like terms, so I'd get my 28x. So I'd have the same answer, if I did it, if I expanded it. Let's try another one just real quick. Negative in here. Let's just say I have 5x minus 9 squared. Now again, as your pre-calc teacher, if I was your pre-calc teacher, I would jump right to the ending, right? And it's pretty easy to do. I square my first term, so this is 25x squared, and then I multiply a negative 9 times 5, right? That's going to give me negative 45, and I double it. So I'm going to have negative 90x. And then I square my last term, and negative 9 squared is a positive 81. Right? So it's pretty easy. 4x squared minus 3y. What's that going to look like? I'll give you a second. Four x squared times 4x squared is giving me 16x to the fourth. Right? And then I multiply these two, which would be a negative 12x squared y, and I double it. So I'm going to have negative 24x squared y. And then I square my last term. Oh, I've got to put my square on. So this would be plus 9y squared. So I said there was another type of special binomial. The other one that we're going to talk about is the sum and difference. And the sum and difference means we're going to have the same values, but with the opposite operation. One's going to be a plus and one's going to be a minus. Or one's going to be a minus and one's going to be a plus. But everything else will stay together or stay the same. These are actually called conjugates. Right? When everything is the same except for their opposite operation like this in a binomial, they're called conjugates. And we could do this the long way, right? We could FOIL it out, or distribute it out, and we would have x squared minus 3x plus 3x minus 9. We could distribute our first term, distribute our second term, and then combine our like terms. X squared, a negative 3x and a positive 3x cancel out. So we're just left with x squared minus 9. And what we'll find when we're multiplying conjugates is this is always the case. So if I have a 2x minus 7, or 2x minus 7, 2x plus 7, right? I recognize that these are conjugates. If I were to distribute it, I don't know if I'm wasting my time here, but if you distribute it, 4x squared, 2 times 7, this will give me 14x. If I distribute it, it looks like that again. 14 minus 14 is gone. I have 4x squared minus 49. So it happened again. So when I'm multiplying the sum and difference, or I'm multiplying conjugates, I don't have to multiply the whole thing. I could just multiply the first term and the first term last term and the last term. So if I have 5x plus 3 and 5x minus 3, I don't have to go through that whole rigmarole of FOILing it all out or distributing it. I could just multiply my first term, 25x squared, and my last term, -9, because these are conjugates. A plus b squared. Oh, that's my binomial squared. No, that's not what I want to do. A plus b, a minus b is equal to a squared plus b squared, which just means we multiply our a's and we multiply our b's. And I messed that up too, because that should be a minus, right? It's always going to be subtraction. So let's get rid of that. Right, a negative b and a positive b. Should always be subtraction because these signs are always opposite. Right? Those are conjugates. So this would be the formula if you're a formula person. Oops. And that's your summing difference. I'm going to turn the page. This course used to be called College Algebra and Trig. I would always put this problem up. I would have this on the exam. And it was a to the x minus b to the y squared. A to the x minus b to the y squared, and I ask you to multiply that. And you could do it any way. So if you want to expand it and write it twice and try it out, or if you want to use a binomial squared formula, you could do that. But why don't you take a second and see if you're able to do this. This is a good problem because it's all variables. So it'll be interesting. All right, the easiest way probably to start this is maybe to expand it. I think most students are more comfortable, that way we could do step by step. If I have a to the x minus b to the y times a to the x minus b to the y, and I distribute my first term, a to the x times a to the x, I want to be aware of my properties of exponents. I keep my base and I add my exponents. So I'm actually going to have 1x plus 1x. This is going to be a to the 2x. Here I have a to the x minus b to the y. Well, it's a positive times a negative, so it's negative. And a to the x times b to the y is just going to be a to the x times b to the y. We can't do much with that. Similarly, I distribute this term, and it's the same thing. I have a negative times a positive, so it's negative. A to the x, b to the y. You always write your terms alphabetically, even though this is b and a. We write a, b. And then a negative times a negative gives me a positive b. I keep my base, I add my exponents to the 2y. Once I've distributed both terms, I could combine my like terms. So here I have a to the 2x, negative, these are like terms, they're both exactly the same. Here I have a -1 and a -1. I owe my brother $1, I owe my mother $1. I am minus $2 a x b y plus And if we look at it using our formula, right, I square my first term, which is a to the x squared, just so you see, a to the x squared. I multiply my exponents when I have it like that, so that would be a to the 2x. And then with that formula, I said you multiply these two and double it. Well, a to the x times a negative b to the y, doubled, which means times 2, gives us that. And my b to the y squared, it's a negative b to the y, so it's going to be positive, because a negative times negative is positive. And when I square it, I'm going to end up like this, 2 times y. So you could have used that as well. You could have used the formula, would have been fine. It's a tough problem, I think, but something to think about.
I have a question.